All right, you guys. So we are up to 2-2 in Algebra 2. This is a whole different ball game. It's going to be a lot of information, but I hope we can just simplify it by helping you understand you need to know mathematically the difference between the word and the word or. There's this word conjunction and disjunction. We'll talk about it, but really the main focus is, do you understand the difference between an and problem or an or problem? And I'm going to try to give you the concept by talking about pizza. So here we got Bill's Pizza. Pepperoni, ham, onions, olives. Sounds like a winner. Sue, she likes sausage, ham, onion, and pineapple. Not a big fan of the pineapple, I don't know about you. But if we ordered, now listen to me carefully, mathematically speaking, Bill and, this is a conjunction, Sue's Pizza, we would look for what they have in common. Pepperonis? Nope. Ham? Yes. So we would get ham on there. Onions? Yes. And that's it. Olives are not in common. Pineapples are not in common. So mathematically speaking, if we use the word and, we're looking for what's in common. Keep that in mind. If we ordered mathematically speaking or, that's the sum of all. So if we look at all that's on Bill's Pizza and all that's on Sue's Pizza, and we just take the sum of it, we would have pepperonis, we would have sausage, definitely ham, we would have onions, pineapple, and olives. Now that looks a little bit gross to me, but mathematically speaking, if you're going to order Bill or Sue's Pizza, you're going to take them all the items added together. All right, now we got to transition and take that logic and apply it to math. Are you ready? So what we have here, and we're going to use these graphs, these number lines, we have x is greater than 2, so that's an open circle up to the right. We have x is greater than 4, open circle up to the right. Now, because of the word and, we're looking for what's in common. So this area right in here is not in common, but where these lines overlap is what they have in common. So my answer for this problem would be x is greater than 4, because that is what's in common with both. Look for the overlapping part of it. Keep that in mind as we go in the world of and. So again, we got the word and. Same picture. X is greater than 2. X is less than 4. So where do they overlap? In here. Now this is very strange, but you need to listen to this. This is already a new idea. How do I answer that? Well, I could answer it by just stating the problem. And that's very unique because this language explains this space. However, we could also use this. X is greater than 2 and it's less than 4. So if you see something written like that, there's an implied and in that language. So you just have to be aware of that. This one, and we're looking for what's in common. Less than 2, less than 4. Okay, where do they start overlapping? Right here. Well, how do I explain that space? I explain it by saying x is less than 2, because that's where it starts and it goes that way. All these numbers are less than 2. So that's my answer for this problem. So this one, less than 2. This one says greater than 4. What's in common? Nothing. So the answer for this is empty set. Okay, let's move on. Transition into the word or, which is a disjunction. Now, is there going to be like test questions like, is this a disjunction or a conjunction? No. You just need to know what the word and means, and you need to know what the word or means. So, what does the word or mean? It's the sum. You just take whatever it is and you add it together. So take that idea and apply it to math. I'm going to use the same drawing here. So I know it's going to look like this, and I know it's going to look like this. So I am looking at x is greater than 2 or x is greater than 4. I should have had that written up there earlier, sorry. But all right, so how do I take the sum of all of this? The sum of all of this, not looking for what's in common, but looking for one thing to explain all of it, would be x is greater than 2. Because if I just look at this one covers this one. So that's why that would be my answer for this case. X is greater than 2 covers the other one. And you answer it as simple as you can, using as little amount of information as you can, and that's why we choose this. So let's go with or on this one. X is greater than 2 or x is less than 4. What does that picture look like? Open circle to the right, open circle to the left. Now this is interesting. Remember what the word or means. You take a look at the entire picture and you try to summarize it as simple as you can. Well, here's the thing. If they go up like this and they go towards each other, the whole number line would be covered. So that means all real numbers. There's nothing that doesn't get covered by that. If it goes up and like that, everything's covered. Let's go to this one. X is less than 2 or x is less than 4. Let's look at the picture. The picture looks like this and like this. All right, now we're trying to answer this with as little language as possible, so we ask ourselves, which one covers the other one? Well, x is less than 4 covers x is less than 2. So this covers, this explains it all. Okay, that's the sum of both of these things put together, stated as simple as possible. Last one, x is less than 2 or x is greater than 4. The picture is going to be the same. So it's going to be like this, and it's going to be like this. Here's a weird one. You try to answer this as simple as possible with as little language as possible. How do I describe this picture? There's only one way to say it. I got to explain this right here. X is less than 2 or x is greater than 4. Because this explains this and this explains this. No, they don't have anything in common, but we don't worry about that because we only think that way when we're talking the word and. So there's my simplest expression for what's going on there. All right, we're going to work more on those sample problems in our packet coming up.